If you turn back to page 1 for a minute, we left the range for these two examples blank, and the reason for that was because of the ellipsis telling us that the pattern continues forever. So it wouldn't be enough to just state 20, 16, 12, 8 for the range, or 80, 40, 20, 10 for this range. We have to actually come up with the formula and state the range that way. So for the first example, this is an arithmetic sequence. Come up with the general term Tn equals a plus n minus 1d. Plug in everything that you know. First term is 20, n minus 1, negative 4. And when you simplify this, you should get negative 4n plus 24. So that's going to be your range. And n belongs to the set of natural numbers because we can't have such things as negative term numbers. We can't have, 1.5 term. All right, and complete the same thing for the geometric sequence here, 80, 40, 20, 10. So Tn equals AR to the power of n minus 1. The first term is 80. The ratio is half to the power of n minus 1. That's really all you need to do for this example. So you can just plug that in for the range. And again, write that n has to belong to the set of natural numbers. And you're done. So turn back to page 4. We're going to go over the last question type number 3. All right, in this last question type, what term is or does blank, so some number, belong to the sequence given? So in this question, you need to determine the value of n. If n is not a natural number, it does not belong to the sequence, meaning the term, rather, does not belong to the sequence. All right, remember for all sequences, n has to be a natural number, so it can't be a decimal value, can't be a fraction, can't be a negative. All right, so let's go over this example. Given the sequence Tn equals 3n minus 2, that's an arithmetic sequence, determine what term is 775. So in this example, we are given Tn as 775, and we need to figure out what the value of n would be. So really simple, just plug in 775 for Tn, rearrange, isolate to solve for n, and you should get 259 as n, so therefore 775 is the 259th term in this sequence. For part B, whether or not 1023 belongs to the sequence. So again, we need to remember n must be a natural number. So n must belong to the set of natural numbers. All right, so do the same thing as in part A. Sub in 1023 for Tn and solve for n. Now divide both sides by 3, and we end up getting that n is equal to approximately 341.67. So as soon as we see that n belongs to the set of real numbers, not the natural numbers, we can say, therefore, no, 1023 does not belong to the sequence. So those are the 3 general question types. And now for the rest of the page, you can do the examples on your own and just pause the video. Every time you've done the example, just press play again and the full solution will show up so that you can see what it is. And in tomorrow's class, we will go over this very briefly, and the rest of the time will be for you to work on the assigned work. All right, so go ahead with the practice questions. Okay, so here's the full solution to number 1. Tn is equal to 3 times negative 4 to the power of n minus 1. For question number 2, you can assume that the first term is 2000, and if you figure out the general term as 4n plus 1996, then plug in 6,388 into Tn and solve for n. You should get a whole number for n. So since that whole number belongs to the set of natural numbers, yes, the year 6,388 will be a leap year. Okay, last example, you should get Tn equals negative 4n plus 3 for the general term, and no, negative 200 does not belong.